Hi everyone, this is a short video on how to calculate distance between lines and planes and other such things, and parallel lines. So I have the formulas written down here. So this is the distance between a straight line and a point, and your formula is here. We're going to do 4 examples. So this is what it would look like. This is your line, the green, and we want to find the distance from this line to this point here. Okay, this is the formula for the distance between 2 parallel lines. Now these are parallel, the A's are the same, the B's are the same, but our C's are different. So this is C sub 1 and C sub 2. So here's your formula, and we're going to do an example, and here's our 2 parallel lines. And the next one we're going to go over is the distance between a point in 3 space and a plane. Alright, so we're in 3 space, and please forgive my drawing. And here's the formula. Of course, this is the formula for distance of a diagonal when you're in 3 space. Okay, so here's an example. We want to find the distance between this line and the point, this point. So we're going to use our formula given here. Distance equals absolute value A x sub 1 plus B y sub 1 plus C. Absolute value of that over the square root of A squared plus B squared. And this is going to equal the absolute value of 2 times 3 plus 4 times negative 1 plus negative 5 all over square root of 2 squared plus 4 squared. Alright, and what we're going to get is absolute value of negative 3 over the square root of 20, which is 3, and I'm going to write this as 4 times 5, so it's 2 root 5, and this would be 3 root 5 over 10, or it would be 0.67. Alright, next we want to find the distance between 2 parallel lines. So I'm going to use my formula here. These are the only numbers that are different here, my C's. And then my A's are the same and my B's are the same. So we're going to get the absolute value of 3 minus a negative 5 over the square root of 1 squared plus negative 2 squared, which gives you 8 over root 5, which equals 8 root 5 over 5, which is a 3.58. So this is using the formulas and knowing when to use the formulas. All right, the next one, we have distance between a point and a plane. So our formula would be D equals absolute value of A x sub 1 plus B y sub 1 plus C z sub 1 plus D all over the square root of A squared plus B squared plus C squared. So we get absolute value of 2 times 1 plus 1 times 2 minus 1 times 1 minus 1 all over square root, I'll make this bigger, 2 squared plus 1 squared plus negative 1 squared. And we get this, we're going to get 2 over root 6, which equals 2 root 6 over 6, which is 0.82. Okay, and the last one, we have 2 parallel planes, so find the distance. So it's just going to be like our first formula, but we have another dimension. So that formula wasn't given earlier because I couldn't draw it very well, since I'm not a good drawer. So basically you're just adding this part to your original formula. And instead of C, we're calling that D, over square root of A squared plus B squared plus C squared. And what we get is 0. We have to find the distance between the planes and find one point on the first plane. So the one point on the first plane we're going to call 0, 0, 1. So when you get that, this is your point on the first plane, this one. So we're going to get 0 plus 0 plus 1 minus 5. Sorry. It's the absolute value of that. All right, so we get 0 plus 0 plus 1 minus 5 over the square root of 2 squared plus 3 squared plus 1 squared, which gives you 4 over square root of 14, which is 4 root 14 over 14, which equals 1.07. And that's all. Have a nice day.